All right, so this was the first one. Remember yesterday I said, because it was happening a lot when I was going through to check them, that people were using the wrong points. When you're trying to find the distance from a point to a line, you are using the perpendicular segment. All right, so if you used P and Q, which is the points you should have used because that was the end of that perpendicular segment, then your coordinate point was negative 2, 3, and then 2, 1. Your distance formula, which is obviously something you need to know for your test, is x2 minus x1 squared plus y2 minus y1 squared. And then you should have gotten square root 20. These are the ones that you have to break down if you can. 20 breaks down into 2 and 10, which is 2 and 5. And then these two bring a 2 to the outside, and the 5 was left underneath. So 2 root 5 is how that answer needed to be written. All right, for exercises 2 and 3, it says determine which lines, if any, must be parallel and explain your reasoning. So when you're looking at 2, the only information you have is angle here and here, okay, which is only on the transversal on the left, which would link G with H. There's no link from E to F. So only G and H are parallel. And you could have used alternate exterior angles there. You could have used the lines perpendicular to a transversal theorem there. So there were 2 answers that would have worked, okay? Either the alternate exterior, because those 2 angles are alternate exterior, showing that they're congruent because they're both 90, or because 2 lines are perpendicular to the same line, which is the lines perpendicular to a transversal theorem. You could literally write it out too. Like if you didn't remember the name, you could write 2 lines that are perpendicular to the same line are parallel. That's fine too. For 3, there was several. First, the one on here, the first one is L is parallel to N. L is parallel to N, and that's because they are both perpendicular to J. M is perpendicular to N, and that is because the either consecutive interior are supplementary, or they are both perpendicular to K. You could have used either one. J is parallel to K. Again, because they are both perpendicular to the same line on the bottom, they're both perpendicular to N. And then because L is parallel to N and M is parallel to N, you can use the transitive property on parallel lines to link L with M. So all 4 pair of those angles would have been parallel. Not congruent, parallel.
So
all right, 4 was your proof, and this can be done a couple of different ways. This is probably the shortest, but it is given to you that angle 1 and angle 2 are congruent. It is given to you that C is parallel to D, and it is given to you that A is parallel to B. No, sorry, B is perpendicular to D. So all of that can be said in one statement. Then 2, A is perpendicular to C because if 1 and 2 are congruent and they form a linear pair, then they have to be perpendicular. And that's the linear pair perpendicular theorem. Again, if you don't know the name of it, you could literally write it out. If 2 angles are congruent and form a linear pair, then they would be perpendicular. Then A is perpendicular to D, and that's the perpendicular transversal theorem that says if a line is perpendicular to one of 2 parallel lines, it is perpendicular to the other one. So because A is perpendicular to C and D are parallel, A is perpendicular to D. Yep.
what is the backwards T mean?
Upside down is perpendicular.
Upside down T.
Is perpendicular. And then the last thing says that A is parallel to B because lines perpendicular to a transversal theorem, which says that 2 lines that are perpendicular to the same line are parallel. Thank you.
So you say
Okay, 5 said to tell whether those points are parallel, or those lines, sorry, would be parallel, perpendicular, or neither. Line 1 had a slope of 2. Line 2 had a slope of negative 1/6. So these are neither. Remember, they have to be the same to be parallel. They need to be opposite reciprocal to be perpendicular. I will be...
Someone sent me misinformation.
That's nice. When you are answering a question like this, if it asks you to find the slope and then determine if they are, like you could get lucky by them just not matching, but if the slopes are not right, you also might lose points that way. So you want to make sure that you're careful, okay? Because the slopes had to be given and then determined if it was parallel. And 6, perpendicular neither. All right, then 6, write the equation of a line passing through point -1, -4 that's parallel to y equals -6x plus 8. So I need to take the slope out of that line, the equation that's given, and that would be -6. Because it's parallel, I keep that slope as -6. And then you can plug that into, this is into y equals mx plus b. You could also plug it into point slope. Y minus a -4 equals m times x minus a -1. Y plus 4, -6x minus 6, and then subtract the 4. And y equals -6x minus 10. So either way, you get the same answer for the equation. And 7, write the equation of a line passing through point -1, 3 that is perpendicular now to this line. So the slope of the line that's perpendicular would be 4, which means the slope of the line we want to find is -1/4. And then you're plugging that in with the coordinate point. Again, this one's in a slope-intercept form. If you did it into point slope, it would be y minus 3 equals -1/4 x minus a -1, which becomes +1. Y minus 3 equals -1/4 x minus 1/4.
So do we have to
Add the 3, hang on. Add the 3, y would equal -1/4 x plus 12/4, which is 11/4. So either way, same answer. If you have extra time, feel free to even check that using both methods.
Well, actually.
All right, this should have been 8, remember, because I duplicated. Okay, so find all the unknown angle measures in the diagram. Justify your answer for each angle measure. So angle 1 is 90 degrees. It's vertical to angle 3. Angle 2 is 15. It's complementary with the 75. That's one of the ways you could have done it. Angle 3 is 90. It's actually marked as a 90 degrees. Angle 4 is 45. It's vertical with the 30 and the 75. And then angle 5 is 15. It's the vertical angle to angle 2. So the reasons don't have to be exactly like that, but the values. All right, let's talk about your test. All right, this is like a brief, like I just took some screenshots of the stuff that are in your book to put on here so we didn't write out each individual thing. But this is a brief of all the topics that are going to get covered on that test. So 3-1 was all of your special angles. This is your corresponding alternate interior, alternate exterior, and consecutive interior. You do just want to be able to identify those, okay? That's part of something like it might just say identify which one is corresponding, and you have to give an example. Alternate interior, you have to give an example, alternate exterior, and consecutive interior, okay? Then in 3-2, we learned that if the lines were parallel, there was a lot of relationships that were set up from there, specifically 4 pairs of angles in which were congruent and 1 that was supplementary. So we said that corresponding were congruent. We said alternate interior were congruent, alternate exterior were congruent, and then consecutive interior were the ones that were supplementary. So with these, you might see something where you're given a diagram in which part of the information is filled in, and it's asking you for angles on the other, like measurements of angles for the other ones. Or this is where we had algebraic questions where if you had angle, let's say 1, and then you had its corresponding angle, you would set them equal to each other and solve for x. Like that was on your quiz. You could see something like that. You might also see this built into the proof, okay? So if I give you that the lines are parallel, then you would know these things about the angles, and that might help you with your proof. Then 3-3 was all the converses. So we said that the important word in there is converse. You have to state it's the converse because now we're flipping it. And we're saying if these angles are blank, then the lines are parallel. So if you're trying to prove the lines are parallel, you have to use the converse. And that is if corresponding angles are congruent, if alternate interior angles are congruent, if alternate exterior angles are congruent, then the lines are parallel. Those are all the converses. And then if consecutive interior angles are supplementary, then the lines are parallel. So all 4 of those are used to prove lines are parallel. And we added the transitive property of parallel lines. If 2 lines are parallel to the same line, they are parallel to each other. So that was 5 ways in 3-3. And then we added an additional one in 3-4, but there were 5 ways in 3-3 to prove lines were parallel. So you either have to know the name or you have to be able to describe that to me. Like if you forget what it's called, you could literally write, if 2 lines are parallel to the same line, they are parallel to each other. Or you can write the transitive property of parallel lines, okay? And you can give me the little symbol for parallel lines, which is like this guy. Like you could give that instead of writing out parallel lines. You could give the upside down T for perpendicular, okay? You don't have to write everything all the way out. That was the stuff that was covered on your quiz, okay? Overall, you guys did really well on your quiz. When I'm done, I'll go back, and I think there was like a couple of things that people, or common mistakes, I'll go back to those in a minute. 3-4 added the 3 other theorems that are used with perpendicular lines, and that is the linear pair perpendicular theorem that says that if 2 angles form a line and are congruent, that those 2 lines would be perpendicular. Then the perpendicular transversal theorem that says if a line is perpendicular to one of 2 parallel lines, then it's perpendicular to the other. And then the long one, lines perpendicular to a transversal theorem, which says if 2 lines are perpendicular to the same line, they are parallel to each other. So this became the 6th way to prove lines are parallel. So we have a total of 6. 1, 2, 3, 4, 5, 6 ways that prove that lines are parallel. Oh, I'm sorry. All right, and then 3-5 was your equations of parallel and perpendicular lines. Okay, this is your finding slope, which is y2 minus y1. All right, so slope, you need y2 minus y1 over x2 minus x1. Mars, there's your correct information if you'd like to write it down so that whoever fed you false information before, it can be corrected. Okay, and that's rise over run. The slope-intercept form of the equation, which is y equals mx plus b, and then the point slope y minus y1 equals m times x minus x1. Parallel lines have the same slope, perpendicular lines have the opposite reciprocal. So all of that stuff was in 3-5. And then the only other thing that was in 3-4 was the distance from a point to the line, which was in that example that we worked through in the class kick. If you're trying to find the distance from a point to a line, you have to use the perpendicular segment endpoints. Mars.
I just want to clarify. So like for example, the opposite reciprocal of 5 would be negative 1/5.
Correct.
All right. Just clarifying.
Okay. Any other questions on the content coverage of your test? Yeah. Yeah. Well, this slide, it will be in the video. I mean, I could post it, but it's going to be teeny tiny. But it will be in the video. Yeah. No. So there are 2 things you can find to do on your own time, and that is this chapter review that goes section by section. There's questions within each section, okay? And then at the end, there's a chapter test for practice. You can actually, on the chapter test, skip 12. And then I would say make sure you're checking your answers as you're going with that one, okay? And then on big ideas, there's more extra practice from just those last 2 sections. So if you know you're feeling comfortable with the beginning and you want to practice, there's also like a proof practice on there. I would strongly recommend that you work on that too. So you've got lots of options, okay? None of which are to do nothing. So I'll let you work for a little bit. You get to choose if you want to pick the big ideas or this one. This has all of it. Big ideas does not. Okay, and then remember tomorrow we're on a shortened schedule because it's math, but we will still go over the review. I have an interactive review if we can do it. We'll do that tomorrow, and then Thursday is your test.